Now I invite Professor Bhaskar to handle the session, please.
Sir, Bhaskar sir.
Good afternoon, participants. Am I audible? Somebody can respond.
Sir, yes, sir.
The PPT is visible. I have shared.
No, sir. You are presenting everyone. Only it is visible, sir.
Right.
Slides are not visible. Yes, sir.
Okay. Good afternoon, participants. I'm Dr. Bhaskar, heading introduction people might have given. So first I would like to thank Sitaraman and the organizers for giving a chance to talk to you for an hour or so regarding the Internet of Things. I don't know how many of you are familiar with the Internet of Things, but this talk is about to make you the basics of Internet of Things. What really an Internet of Things is. Because it's becoming catchy and it's so popular as far as the institute as well as industry is concerned. I'll be able to give you a guideline or maybe basics of Internet of Things. So I'm going to give the functional blocks of IoT, then physical design and logical design of IoT, and what are the technologies where IoT can be used, and what are the different levels of IoTs. Because all of them need not have to work in all the levels. So depending upon the application, they can select the level of IoT and they can work on it. And feel free to interact if you have any queries. Or in my talk, I'll be asking questions. So probably, if you know the answer, you can respond. I don't want to my talk to be monotonous. So if you know the answer, probably you can unmute and you can give the answers. Okay. So first thing is the definition of IoT. The first thing you have to understand, Internet of Things. Somebody who is already working or familiar, probably you can share your thoughts. What do you mean by Internet of Things? Answers, please. From your perspective, or from the word that you've heard, Internet of Things. So, what do you know or what do you understand by Internet of Things? Any answers, please? So, feel free to give the answer. What do you know about Internet of Things? Am I audible to the participants? Somebody can respond.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Yeah, then somebody can give the answer. So, what do you know about Internet of Things? Okay, fine. Normally, it's a terminology. I can say Internet of Things. It involves so many technologies together. It is not just one technology like other one or other technologies that you learn in communication. So it is a combination of so many technologies. As far as the IoT definition is concerned, the first thing is physical thing. What do you mean by physical thing? We have electronic gadget. You take a mobile phone, that's a gadget. You take a printer, which is having its own IP. It's a device. You take an Arduino board, or you take a Raspberry Pi board, your laptop. All electronic gadgets which are provided with a unique ID. That's very important. Note down the word. Unique ID. Okay. So each device can be identified with a identity, or could be identified by a identification number. Normally we call it as IP, IPv4 or IPv6. So some numbering will be there for each and every electronic device, and these electronic devices are actually called things. Okay. Then next is internet. So you are going to connect these things to an internet. Most of the students in my class, they'll ask for IoT, sir, necessarily I need an internet. No, that's my answer. Even you can have your intranet. You can have your own network, and you can have a connectivity within the network, and even you can have your IoT application. Okay. So that's why it is internet, means it is a communication. That's why next point I've given. Sending, receiving, and communicating information using any one of the network topologies you have. Okay. Need not be internet, even some other topology you have wherein you can communicate, that is also holds good for your IoT applications, right? Then I have devices and they are being connected with the unique ID and they are having facility to communicate each other. What I'm going to do with this? Okay, so I'm going to monitor, right? You have sensors, so what the sensor is going to give some information. For example, you take an IoT, put on an agricultural land. So probably you would like to monitor the moisture or the rain or the crop color or something. So you have to monitor. You have to coordinate certain activities and you have to control. So if you do all these things, so probably that will be the activity that I want to do. Okay. The next important thing is I must be able to dynamically configure and I must be dynamically able to do certain activities. What this means is, for example, you are connecting a new node or a new network node to any of the already existing IoT infrastructure. It should be automatically self-configurable. You should not go and make a program for enabling and disabling. The moment you connect, it should be automatically configured on its own. It should start communicating. Okay, so this is a quite common now. We call it as plug-and-play device. This is the terminology the industry is using. Just you plug in, automatically it will start functioning or it will start working, right? Then next is you should have some standard protocols. You cannot have your own protocol. There are certain standard protocols which are available. So based on the protocols, you will be doing all these things. What is that? Monitoring, coordinating, controlling, and all those things. And as far as IoT is concerned, IoT platform is concerned, there are two categories. One is you just get the data and you do process the data and do some analytics. That's it, over. Okay, this is one way. Now, another way is you get the data, do the analytics, and you do the reverse also. You'll be able to do the controlling also. That means your IoT becomes two-way. Okay, so certain IoT platforms, it will be implemented on one way. Just get the data, monitor and analyze and predict and do some activities. Where in some cases, in real time, where you have to do some action also. For example, in the case of agriculture, you measure the moisture level, you measure the temperature. If it is low, probably you have to give some watering or some kind of thing. That means you have to do the other way also. You need a control mechanism, you need actuators and all those things. Okay, but if you globally look in, IoT has both a kind of thing. If you do one way or you can do on the controlling also. So you combine all these things, you will get a definition for an Internet of Things. The first thing is Internet of Things should have a dynamic network. That's the first important thing. What do you mean by dynamic? The moment you connect, it's a plug and play device. It should configure on its own and it should start communicating on its own. Internet of Things means dynamic network where you have a physical things with unique IDs we are connected. Okay, and what they do is they will communicate within themselves or they'll transmit and receive with the standard protocols, right? With the existing technologies, which is used to monitor, control certain process within your own network or would be through an internet. So if you have this kind of any network, so that you call it as the IoT, and this is the basic definition of Internet of Things. Okay. Then the functional block, or we call it as basic block of IoT is, so you have a sensor. As I told you, it's one way or two way, that depends. So sensor to sense the information, and thing is nothing but a device. Could be a small processor. We are going to see in detail about these things. Then you need some minimum communication which is required. So your sensors connected to a small processor board with some communication protocol which is connected to your local network. Okay. So even this could be a simple or a small IoT model. Then the local network will be connected to the internet through a gateway. Okay. So why I'm supposed to do this is if your data handling is very high. Okay. So the sensor data that you are getting is a very huge amount, and the amount of processing that you want to do, which cannot be done with the small processor which is available in the thing, or you cannot do it with your network, then probably you have a gateway. Through gateway, you connect to internet, and you'll have a server, cloud, all those things where you do your data analytics. Okay, and after doing the analytics, then I want to do the control. This is sensing, the other end is control. So probably I have to go with the same path, and you activate the actuator, and you will be able to maintain the required value or the required environment. So this is some simple model that you can find in most of the IoT devices. So you can have two parts. One is called the device level. This is available as a single board with IoT boards that you find in the market. Whereas network level, you need your infrastructure. If you are working on an institute or research organization, probably you'll be able to have your own network, and definitely you'll have a gateway, IP gateway, and you can connect to the cloud or a server. If you have your own server, you can have data analytics there with the data analytics software that you can buy. Or already Google, then Intel, or most of the companies, they are providing the service. The cloud service, so you can get the service from them and you can do it, but probably you need an IP gateway to connect them. Okay, so depending upon your application, you can do IoT within this level, and with your own network, you can perform some IoT applications, or you can connect to the gateway, and through a gateway to a cloud, and you can do the analytics. Okay, so depends upon your research problem or the magnitude of your problem that you take or the solution that you find. Okay, so thing basically it contains a sensor and a small board and a small unit, as I told you. As I told, network could be your own network or intranet, which will be available, and you have an internet. So all these things you put it, so that's the functional block of a IoT based system, right? We go with a little bit detail about the thing. It's basically an embedded system. The thing is an embedded system. Minimum you need some sensors and actuators. At least you need a microcontroller and a communication unit and supply. The supply is concerned, most of the time these things will be deployed in a remote place. Sometimes you need power backup with the solar, or you have an inbuilt rechargeable battery. So these are certain things you have to plan very beginning itself. Okay, so you need a battery to be recharged, or you have to replace the battery frequently. So automatically the demand which comes to the thing is the power consumption. Okay, so the thing or the device, electronic device that you're going to put with the sensor and actuator in the field should consume less power. So this is really a challenging or real research work that the researchers can take. I need an IoT sensor and I need a small processor attached to that, and it should communicate to the nearby node or a nearby network where it should consume very low power. Okay, so that's really a challenging thing as far as the IoT industry is concerned. Designing a very, very low power IoT node, or we call as IoT thing, which are minimum sensors and a control unit and a communication unit with a minimum power it can operate, or the battery that you put will last for months or 6 months or years. So how you're going to design it? So that's really the challenging task. Okay, but if you go to the market, readily available IoT board you can buy and you can do something. But power, it's a question. So researchers definitely have to take into account this point, and probably you can think of and you can do research on this. The next is sensors and actuators. Instrumentation students or instrumentation department professors will know large about sensors and actuators. But as far as IoT industry is concerned, it is mandatory that we have to use large number of sensors and actuators. So at least have some idea about sensors and actuators. It is very important. There are large number of sensors available. So I can say 40, 50, even more than that. I have a complete list. Probably I'll share you at the end. Okay. So the first difference is sensors is input device and actuator is the output device. It's a fundamental property that you can have in mind. Sensors will collect some information which is available in the surrounding section or surround, and that will be converted into electrical signal and it will be given to the board. As far as the sensors are concerned, there are three types. One is passive sensors, omnidirectional. Passive sensors which will operate for a particular band or a beam, then active sensors. So these three types of sensors which are available in the market. So the list, as I told you, I'll give at the end. Actuators are concerned, basically we have a relay or a solenoid or a heater or a buzzer which is used to have some activity. We don't have that much of actuators or the output devices. Even this is a research. You can have MEMS devices or mechanical and instrumentation or electromechanical devices, very accurate actuators which will do very perfect activity depending upon even the smallest variation in your signal. So this is also a research. Designing actuators is coming up a new research area. So probably mechanical and instrumentation combined with electronics, we have to work more on it to design very good actuators. But sensors, we have large variety of sensors. But actuators, we don't have that much. It's a very minimum. If the IoT industry is going to pick up, and a simple example I'll tell you is, for example, biomedical engineering. I want to inject insulin to the patient depending upon the sugar level. Do you have any actuator which will exactly introduce 1 ml or 2 ml insulin into your blood? Do you have any actuators? Sensors we have. We have laser sensors. We have so many sensors which will measure the glucose level and it will tell you. But do you have an actuator which will exactly inject you body implantable actuator, which will exactly inject you the required amount of insulin? This simple example, like actuators, it's really an area where we have to focus more. The researchers should focus more. Okay. So when coming to the communication, it's very important because it is going to provide communication from the sensor to the board. And not only that, you will have so many local nodes. All those nodes, they have to communicate between them. And all these nodes which will be communicating should be communicated to the nearest network. Okay. As far as this communication is concerned, the communication could be wired communication or wireless communication. Okay. Wired communication means you can use copper or fiber. It's costly, that you know. You have to physically lay your cables, Cat6 network cables or twisted path cable with ADSL modem. You have to communicate, or you have to have your optical wires with the transmitters and receivers. Okay. Or you can go with wireless RF transmitters or IR transmitters and receivers. But RF is the popular choice as far as IoT is concerned. The reason is most of the IoTs are used in industries or where you cannot have large number of wires which can be used for communication. For example, you take an automobile industry. If you want to have a wire network in your car, the fully automated car and all, so communication wires within the mechanical parts of your car, so that will be very difficult. Or providing a network, sensor network in your car, running wires will be difficult. Rather than you have a wireless node, there are 10 nodes available. All those 10 nodes are communicating wirelessly, and from there it communicates to your nearest server node wirelessly. So that becomes the easy solution than your wire. So most of the IoT applications, people will prefer to go with wireless solution on the entry node is concerned. When it comes to the network and gateway and other things, we go with the wired communication. Okay. And as I told you, you need some protocols, communication protocols, standard protocols. Based on that only you'll be using it. There are so many wireless protocols which are available in the market. Zigbee, Bluetooth, Wi-Fi. These three are the popular standards IoT devices will use. And slowly this NFC is coming, near field communication. This is also slowly coming up with an RFID. So this is about wireless communication protocol that you can find in IoT. Coming to the network, as I told you, you can have your own network with the wired network or wireless network. If it is wired network, you have a topology, right? A network topology, mesh topology, so many topologies which are available. Whereas it's wireless network, there are a large number of networks which are coming up. WSN, wireless sensor network, body area network, wireless low power body area networks. Like there are so many networks which are coming up, but all are, I can say, try to handle its own traffic. Okay. So the very important thing, the last point, the important issue with your wireless network is your reliability. Okay, so reliability and performance is a very important concern as well as your wireless network is concerned. Okay, coming to the internet, so I've shown you pictorially. So you can have these IoT boards, and each of these IoT boards can be connected to the sensors. The first network that you have to establish is the network between these nodes, local nodes we call. Okay, and local network. So this is very important. This is called your local network. You can use it for biomedical application or your automobile or for agriculture. So definitely you need this network setup for IoT. And in the beginning, as I told you, IoT can be just this. You have your internal nodes and it's being networked properly, and you can do your monitoring, controlling every activity. Then this is a small IoT platform. Okay. It is not necessary that every time you have to connect to the gateway and you have to go to the internet or a cloud. It depends upon the application or the demand. Okay. So you can have your own network, and if your capability, the requirement is very higher, then probably you should get a gateway from a service provider, and then you can connect to the internet or a cloud. So that's about the basics, and some of the important terminology that people will use in IoT is data ingress and egress. For example, you type Google, and in Google you are just typing a keyword IoT, and immediately it pops up with so much link, and you open a particular link, and each link you are able to get the information, and you are reading that information. Okay, so that means you are getting your data from the cloud or the service provider, Google, the nearest service provider, and that data is coming through internet path to your laptop or to your system. So that is one part. Okay. On the other hand, you are typing an email and to your friend, and you are typing some information and just send. Then your data is uploaded through the same internet path, and it is reaching to the, for example, use a Gmail. It goes to the Google platform, and from there it reaches your friend's laptop or your mailbox. Okay, so there is a two-way data flow. So this is being quite familiar to us, but that is being defined as ingress and egress in your IoT platform. Okay, so if you have your data flowing from your local node to the network, and from the network through the gateway it is going to the internet, so that traffic you call it as egress. And whereas from the cloud through the internet or through the gateway it reaches to the local node or to the sensors or the actuators that you have, so that traffic you call it as ingress traffic. Okay, so for normal internet we use different terminology, but here in IoT If you refer, people will use ingress and egress as two terminologies. And second thing is data aggregation. So here also it's very important research area, which is slowly coming up, or it's having demand. First of all, why I need a data aggregation? What is the need I should do data aggregation? For example, you take a biomedical network or a body sensor network. You are monitoring the body temperature at different parts, and you are transmitting, right? So you have node 1 and 2 and 3. Each node is transmitting some data to the fourth node, and this fourth node is transmitting to the base station, right? Okay. And if you take these three nodes will be continuously sensing the data, and it will be sending to the fourth node. So how many data packets you are receiving per minute or per second that you calculate? Just three nodes, the number of packets that you are getting will be only 3. So, but if you have large number of nodes where the data that will be coming to node 4 will be very high. So the traffic on the node 4 will increase, or the aggregation node should do overloading or should do more work. Then only it can handle all the data which is coming these nodes, and it is supposed to transmit to the base station. But all these two should happen before the next set of data should come to this aggregator node. Okay, so when you have a large number of nodes, it becomes some aggregation I have to do in the node 4. Okay, so what do you mean by aggregation? In the example I told you, I am getting a temperature 1, 2, 3, right? I can have a criteria that if there is a change in temperature, then I have to send this. I need not to send the same temperature which is coming in every second to the base station. Okay, so I can have some logic here, aggregation logic here, which can be programmable in the node, where if I have same temperature, I need not to send, I can discard or omit them. If there is any change in temperature within a second or within a minute, then immediately I have to send the data to the base station. Okay, so basically aggregation is how to handle the data, the real-time data which is coming from all these nodes should be transmitted to the base station. Do I have to transmit everything? If you have a smaller network, okay, fine, but you have a large network, the aggregator node will be overloaded, or sometimes you will not be able to handle the traffic. Okay, so definitely you should have some aggregation methods. The user should have some aggregation methods. So based on the aggregation methods, you have to aggregate your data. So then only you will be able to handle your data effectively. So here is the example. Here all the 3 data is going, but here I'm sending only 1 data based on the aggregation logic that I'm using. Okay. Then what are the logics? Probably I can go with it. As I told you, duplicate sensitive. If your node is sending same data quite for some time, you are sending a duplicate data. So probably you can have an algorithm. You can find an average for a particular second, or you can find an average for a minute. Then you can send the data. Need not have to send every minute or every frame. You have to send it. So if the data is duplicative, then your node will sense it and properly it will do it. In some applications, no, even it's duplicate, I have to do it. Duplicate insensitive. So there I'll be able to use the minimum and maximum. Minimum and maximum value will be available. These are some guidelines or basics by which we can do it. And the next part is lossless aggression and lossy aggression. Most of the communication people will know that it's basically the compression. Yeah. Yes. Basically, it's a compression. Your sensor will be giving you data in a digital form. So that digital form, can I have to continuously send it, or can I compress and send it, or do I have to send continuously without compression, or depends upon the quality of service. Okay, so quality of service. If you want to have a good quality, definitely I have to go with a lossy aggression. No, my quality is okay, but I want to do the fastest data transfer, then probably I have to go with lossless. So there will be always an optimization which should be done for lossless or lossy aggregation. So here comes what all the physical things which will be available in IoT. So as I told you, you have to have the sensors, and these sensors will be connected to a small board, embedded board. And how to connect the sensors, that's an interesting thing. Different manufacturers will provide you different standards. Some will give common standard serial port, some will give I2C, someone will give CAN bus, someone will just with an USB they will do it. So the IoT designers, what you have to look in is the compatibility. The sensors which are available in the market now, they have the A2D or data handling is being done in the sensor board itself. If you talk about 5-10 years before, you have to take a sensor, have an A2D converted, and have a chip which can communicate to the protocol that you need. You have to design on your own. But now the IoT sensors available with the communication protocol itself. You have, for example, you take a temperature sensor. You just take a sensor in the market, it has its temperature sensing, A2D. You want to have a serial output or I2C output or a CAN output or USB output, it's readily available at a cheaper cost. Okay, so only thing is you have to take the sensor and actuator which are available in the market and which is compatible to the board. That only you have to look in. Okay. So depending upon the board, you have to select that interface and also the sensors. Right. The next important thing is memory and storage. The board that you are using, a simple Arduino board or Raspberry Pi board that you are using, will definitely have a processor. The on-chip memory or the memory on the board will be adequate to have some minimum processing. So that you have to look in. And the storage available is enough to store the data. Okay, so the data that you are sensing may be frames per second or frames per minute. At least to store that data or to do some minimum aggregation, to compare the successive temperatures or to compress your temperature value and transmit some minimum processing, I must be able to do it here. So the board that you're selecting should be capable of having storage, the memory storage, and also it should be able to have some minimum processing facility which will be available. You need not to have an exhaustive thing, but definitely you should have some minimum processing which will be available in the board. So the board that you are choosing, you cannot just randomly choose it, but you should have this in mind. And the third important thing is a programmable interface. So the local node or the small node that you are having, you must be able to do some programming. Okay, so you have to have some aggregation protocol or something that you want to do. So you should have an option to program it. So that's important. And second thing is this node will be connected to your network. It could be an intranet or internet. So you have to check this. Either you have an Ethernet connectivity or USB connectivity. No, I am doing a wireless network. Then definitely the board should contain a wireless transmitter, either a Zigbee or a Bluetooth or a Wi-Fi. That the transmitter and receiver should be available. So that's why the physical device that you are selecting for the node, that key device or key important things, you have to look all these aspects and you have to look in. But some of the nodes, even they have GPU, graphics processor units are available, but the nodes will be costlier. Okay, so when you are selecting the local node or a physical device for the IoT, so these are important things. So what type of interface, whether your board is capable of doing it, minimum processing, can I do it? For doing that processing and storing the data, and do I have a minimum memory and storage facility? And after doing that, I have to transmit this data to the next level. So do I have that facility? So if you have all these things, good, you can buy that node or a board. And after buying, okay, it's not supporting, then no point in using that particular IoT thing, or we call it as the board. Okay, But the good thing about the IoT devices, most of the IoT devices, they are now have that SD card. So you can just have an SD card, put it, and you can handle your processing, storage, and everything in the SD card itself. So that's why you can see that SD interface is separately given. SD, MMC, SDIO. So this is very popular in most of the IoT devices. So you will have a microcontroller or a DSP available, but memory they don't give extensively. Only with on-chip memory of the chip or the manufacturer they will give. But the remaining storage they have facility to connect your micro SD cards. Now coming to the protocols, these 4 layers definitely will be there. Same in your network, computer networks. People might have studied this. 4 layers: link layer, internet layer, transport layer, and application layer. And if you're doing a small IoT sensor or a small IoT network or IoT platform, probably you will be working in 1 or 2 layers, where you are working on a cloud and you want to have your API and you want to have your own GUI. So probably you have to work on all these layers. Okay, so link layer. So you have your protocol. Internet probably will use IPv4 or 6. Transport layer, TCP, UDP. This is famous. And coming to the application layer, your HTTP or Telnet. So these are the application protocols people will use. So this structure, if you are already familiar with the network, same protocol, but magnitude is very small in your IoT, but in your normal network, the size of handle or the traffic you handle will be very high. Here it's very less. Coming to the first link layer protocol, as I told you, if you are using wired network, simple Ethernet protocol is enough. 1 Mbps or 10 Mbps, it's readily available. If you are using wireless, probably you can use Wi-Fi or WiMAX, LoRa. It's a very popular thing, and LRWPN, low rate wireless personal area network protocol. These are IEEE standards, so any one of this protocol is necessary to have in your link layer. So don't confuse with the link layer. It's nothing but you have a Raspberry Pi board or which is connected to a sensor. So that device should have a minimum link layer protocol. As I told you, should communicate to the nearest node. Okay. Some of the boards, they have the SIM facility. You can put your SIM, so that will do the transmission. You can have your 2G, 3G, or 4G. We call it as GSM modules. CDMA modules will be available to which you can communicate. So this is for your link layer. The next layer is network layer. If you take any IoT device, definitely it should have its own ID. As I told you, so the standard is IPv4 or IPv6. If you are sitting with your desktop or laptop, go to command window, type ipconfig/all. So on the right hand side, what I have shown will come. There will be an address called IPv4 address. Because your laptop now it will be connected to the internet. Through internet only you are listening to my voice, any part of the country you are. So definitely you could have used one of the address, IPv4 or IPv6. Okay. Even you take your router, your BSNL, ADSL router or Ethernet router, definitely there will be an IPv4 address. This is the thing I called unique address. Each and every laptop, your mobile, every communicating device will have its own address. Just type this ipconfig/all in command prompt, you will get it. The IPv4 address, it is 32 bits. 10.1. This is quite common in most of the institutes, most of the organizations people use. And this IPv4 address will be managed by your own network, your internal network. And you can connect to over 32 devices. Okay, so you can count down. So this many devices can be connected within your network. Okay, if your network is going to be connected more than this 2 power 32, then I cannot go with IPv4. I have to move to the next standard, IPv6 protocol. If you're working in an organization and your institute is providing IPv6 network, You connect your Wi-Fi in your institute or internet in your institute, same laptop or desktop, you type ipconfig/all. Instead of IPv4 address like this, you'll get an IPv6. Okay, IPv4 also will be there, IPv6 also will be there. IPv6, basically this same as IPv4, and there are some extended things, subnet ID and prefix. So these being added, whereas this 4, it is same as this 32 bits. Okay, this 32 bits, it's quite common. So there are 4 more IDs are being extended, subnet ID and prefix ID. So that becomes IPv6, where you can have 3.4 into 10 power 38 devices which can be connected. Nobody can imagine this size, but probably your home automation, your cars are being automated, where all of them, excuse me, all the nodes in each and every car has its own IP. Probably we'll be able to go beyond this 3.4 into 10 power 38. Your washing machines will have IP. Your microwave oven will have an IP, or all electronic gadgets in your home. Probably one home itself will be able to use 100 or 200 IPs or device IDs. Okay, and as far as IoT is concerned, is LOWPAN, low power wireless personal area network. This is slowly picking up. Most of the research papers are coming with this low PAN. So that's a new protocol. Coming to the transport layer, TCP and UDP, this is quite popular. Just few information I'll give. TCP is stateful protocol, whereas UDP is stateless protocol. This is typically used with handshake and acknowledge kind of mechanism. So I'll give a table that will give you the better idea. So TCP is a reliable thing, UDP is unreliable. The TCP is an ordered communication transport layer protocol. This is not ordered. This is heavyweight. The packet size will be very big, whereas it's very small. It definitely be used for datagrams, not for data file transfer. We'll be using it for datagrams. This is being with the streaming, but this is your broadcasting. Just transmit and forget. Then coming to the application layer, HTTP is quite popular. All of us use browsers. We just type HTTP. Then CoAP, WebSocket. So these are popular in IoT devices. And MQTT and XMP, DDS, AM. So this you'll find in most of the IoT service providers. Because HTTP is quite popular for your World Wide Web. And this WebSocket, MQTT, XMPP, DDS, and AMQP. So these you can extensively find in most of the IoT service providers or IoT designs. Coming to the logical block, the physical block, it talks about the device communication and all those things. But now coming to the logical block, how you are going to manage, right? You are going to manage your device, you are going to have your communication, that's it, your physical is over. Then what type of services you are going to have, what type of control you are supposed to have. Security is very important thing as far as IoT is concerned. Most of the industries or most of the application providers or the users are not listening to IoT because of the security. Okay. As of now, we have only minimum security as far as these IoT networks or IoT devices are concerned. This is also a very important research area which is booming up, providing data security for the IoT platform. Okay, how really you can provide data security for your IoT platform? You are getting the data, for example, you are doing weather monitoring, right? Large amount of data is available. So how to authenticate and how to deliver to the authenticated users. You should not deliver the information to whoever is asking. For example, you take an hospital, you are taking the biomedical data of a particular patient. If somebody is coming and asking you, give the data of that particular person, you should not give it. So validating security and authentication is a big question mark as far as the IoT device or IoT platform is concerned. So this is also coming up. As far as application is concerned, every industry would like to use the IoT platform or IoT application. They are ready to do it, but there are some bottlenecks which are available. So probably if those bottlenecks are being cleared or being removed, probably every industry would like to or love to go with IoT. Okay, so only certain communication models which are available, request response. So your client will send a request, your server will respond, it will acknowledge, then your communication will start. Then another one is publish, subscribe. So this fellow will just transmit, the other fellows will receive. The best example for this publish, subscribe is you get a large number of SMS and MMS from the mobile service providers, right? For example, Corona, you have received large number of SMS and MMS. It's just published, and all the mobile phones it received it. Okay, you cannot communicate back. Whereas you take a normal SMS or MMS, it is sent from a particular person. If he is communicating, you can send a reply. Okay, so publish, subscribe, it is being used normally for promotions. A particular company would launch something, so whether you want it or you don't want it, you will get a message, right? So that is your publish, subscribe model. Next is push-pull model. You will have a large amount of data which is supposed to be transmitted and received. So definitely you'll have a queue. Okay, so use a push-pull model, and then one more model is exclusive pair. So these two are for a large amount of data handling. So people will use communication models. And coming to API, application program interface, reset-based API or WebSocket-based API. These are purely technical terminologies when you start your programming of IoT devices. So just know the information, that's more than enough. Coming to the technologies, as I told you, as of now, most of the IoTs are concentrated on this wireless networks, wireless sensor networks. Large amount of research is going on, and now these two terminologies are quickly picking up: cloud computing and big data analytics. But yet to come, all these things. Okay, your embedded devices, I need IoT and the security. As I told you, data security and authentication, you need it. And communication, we don't have IoT now, and web services and mobile and internet services. So if you take IoT, where I can use all these platforms I can use. As of now, we are talking about only wireless sensor networks, cloud computing, and big data, but a lot more where my IoT technologies can be used. Coming to the levels, as I told you, depending upon the application, you can have 6 levels. Make a note of it. Or even you refer any standard textbook on IoT, the 6 levels will be given. The present scenario, we are working on only IoT level 1 or 2, or probably 3. Only big companies like Google or Intel, they are working on level 6. Even that's a doubt, because they are not using the two-way. Okay, all are doing one way. They are not controlling some mechanism. So level 1 is, I can check, you have a sensor, you have some device, and you'll be able to have some minimum monitoring or so minimum communication which will be available. Okay, so you just sense, you write some program, and you just activate a relay or make a buzzer to sound once it reaches a maximum temperature. So if you do this kind of activity, that level 1, probably home automation is an example, with a minimum node and the minimum processor and minimum memory, you do in the local node itself. So that is your IoT level 1. Okay. The next IoT level 2, from local node you connect to the nearest network. As I told you, you can have your intranet. Need not be go to gateway and to the cloud. So you can have your local node, and you have your data available in the local node can be connected to intranet which is available, and you can do some analysis here, and based on the analysis you do some activity. So smart irrigation, so the next level. So you do the analysis, then you do actuate, and you do it in the next level. And the next is level 3. Slightly you go and have your server from the intranet. You just have your own server. In the server, you can have some data analytics software, which is your own, or you can get the already existing data analytics software, and you can do it. So that is level 3. Data is stored and analyzed in the server or cloud, and you can do the analytics there. That is level 3. And level 4, where you have multiple sensor nodes. Okay, so you have large number of nodes, and all of them, the minimum processing you do at the node. You have to do aggregation, compression, lossy, lossless, everything, and that will be transmitted to your intranet. And the minimum service that you can do, analytics you can do. So that is level 4. From level 4 onwards, you have large number of nodes which are being connected. And level 5, multiple nodes and multiple applications, and you have your coordinating node, so that will be connected to the cloud. So this is level 5, and level 6 is the ultimate. You will manage everything in the cloud, your data analytics, and everything will be done in your cloud itself. Okay, so this is level 6. As I told you, even when you are doing level 6, do you do the other thing? You are getting the data, you do the processing. Can you actuate something? Still now, that's a question. Nobody is doing that two-way. Everyone is getting data, doing analytics, and they are telling, but the other way, they are not doing it. As I told in the beginning itself, still now we are not having good actuators, which we can do as fast as my sensors. We have large number of sensors, large research we have done, and large variety of sensors we have, but actuators we don't have that much. Okay, so with this I stop. So let me summarize. I have given the basic block of IoT and the physical design of IoT. Basically, IoT device will have what, and logical design. Typically, it's the communication protocols that you write, and what are the IoT technologies which are available, and what are the IoT levels we are working in. So if you have any queries, feel free to ask, or you can take my mail ID from the organizer. You can send your mail. Okay. As I told you, this is only an introductory talk in IoT, but we are offering an elective on IoT. So there we will be talking about each and every part. For example, sensors. As I told you, there are 40 to 50 sensors. So all the sensors, actuators, in detail we'll be discussing. So probably send a mail, I will be able to share you the details. Thank you, Dr. Sridharaman, for the opportunity. And so any queries from the participants, most welcome. If not now, you can send a mail. No need to say that you have attended this workshop and all. Just you say you are from this organization, and I have this. I need this information. Send a mail, so I'll be able to reply with pleasure. Thank you. If you have any queries, I'll wait. Otherwise, I leave the podium, or I leave the link to the others. Thank you.
Thank you, sir. Sir Sridharaman, thank you, sir.
Yeah, most welcome. Most welcome.
Yes.
Professor, thank you for your valuable and informative session.
Yeah, it is only an introductory session. Probably you have a full session for a week. That will be better. So hope we will be organizing in NIT like we have done for DSP and VLSI. Okay, thank you. Thanks for the
Participants are requested to fill the attendance form.
Shall I leave, Sitaraman?
Sir, yes, sir.
Thank you. Thank you very much.
Thank you, sir.
All the best, participants. You have 4 more days ahead. Probably hope you will enjoy these sessions. So make your workshop an interactive one. Thank you.
Next session will begin in another 5 to 10 minutes.